Hi everyone, welcome back to my YouTube channel. I am Reeti and I am back with another lecture in the DBMS series. So in the last couple of lectures, we learned more about normalization and denormalization. In this particular video, we would be learning about functional dependency, which would be really helpful in understanding all the normal forms such as first, second, third and BCNF. So without any further ado, let's get started. Now, as the term suggests, functional dependency. So whenever there is a kind of dependency which is present in form of any function, we can call it as functional dependency. You might have heard about the terms such as equations or functions in maths. Now, if there is a function given y equals to fx, that is y is a function of x, where fx is equal to x square plus 2x plus 1. So if I know the value of x, I can determine the value of y. So what I'll do, I'll just put the value of x here. So that would be 1 plus 2 plus 1, that is 4. So here, if I know the value of x, I can determine the value of y. So y is a function of x, so we can say that y is functionally dependent on x because whenever we know the value of x, we can find the value of y. Now, in functional dependency, it describes the relationship between the attributes in a relation. So, attributes you can say as columns and relations you can say as table. So, whenever there is a table, consider that this is the table name is R, or we can say it is a relation where we have two attributes x and y, we can say columns. So, if y is functionally dependent on x, it means if I know the value of x, I can determine or find the value of y. So a functional dependency is a constraint between two set of attributes in a relation from a database. So it's not important that it will always happen between single attributes. There could be a set of attributes which could be functionally dependent on some set of attribute. So consider that in a table there is a primary key. Now primary key can either be a single attribute or can be a set of attribute. So if roll number is something which is being repeated for each or every person in a combined branch like CSE, EC, so there could be a possibility that in CSE also a person is roll number 1. In EC branch also there is a person with roll number 1. So what we will do is we will take a composite attribute, we will combine two attributes to make it as a primary key or a unique identification key using which we can find the details of that particular person or that particular student in a college. Now for a relation table R, if there are two attributes x and y, then we can say the functional dependency is x determines y, or we can say y is functionally dependent on x, where y is called as dependent and x is called as determinant. So x is called as determinant because if we know the value of x, we can determine the value of y, and y is somehow dependent on the value of x. So if I know the value of x, I can find the value of y. Consider in a normal table that if there is a roll number and there is a name. So if I know the roll number of any person, I can tell the name of that particular person. So roll number is kind of a determinant and name is kind of a dependent, and name is functionally dependent on roll number because if I know the value of roll number, I can determine the value of name. So attribute y is functionally dependent on attribute x. So y is functionally dependent on attribute x, or we can say x determine y. Now, if x is equal to 1, we can find the value of y. The same example which I show here, that if we know the value of x, we can find the value of y here as well. Now, functional dependency x determines y. xy is a subset of the relation. So if there is a table or there is a relation, then x and y is always a subset of that particular relation. Here I am talking about subset, but what subset exactly is? So let there be two sets A and B. Now A is having value 1, 2 and 3 and B is having value 1, 2, 3, 4 and 5. Now A is a subset of B because every element of A is also an element of B. So we can say that A is a subset of B because every element of A, 1 is also present here, 2 is also present here, 3 is also present here. So A is a subset of B because all the elements which is present in A is also present in B. But vice versa is not true because 4 and 5 is not present in A. So we can say that A is a subset of B because every element of A is an element in B. Now here there is a table employee ID, employee first name and employee last name. So here there are some of the functional dependency which is provided. So first is that employee ID will always determine employee first name. So let's see if employee ID can determine employee first name. So if I know the employee ID as 1, is there any employee ID with 1 existing in this particular relation? No. Now in correspondence to 1, what is the employee first name? That is Riti. So if I know the employee ID, I can know the employee first name. So we can say that employee first name is functionally dependent on employee ID, or if I know the employee ID, I can find the employee first name. So you can also say that in functional dependency, the X is kind of a unique identification key. Unique identification key. So basically this is a unique identification key which help us to identify or determine or find the value of Y when we know the value of X. So for this employee ID also there is no 2 which is present in this particular column. So the value would be Rahul. For 3 there is no 3 which is present in this employee ID column. So we can say the value would be Suraj. So we can say that employee ID is determining employee first name, or employee first name is functionally dependent on employee ID. So employee first name is functionally dependent on employee ID. In the same way, employee last name is also functionally dependent on employee ID. Now here you will say that you have written the functional dependency, but how will we identify that if there is a table or there is a relation, what are the functional dependency which are existing? So the first way to determine that is that if there is X which is determining Y, X can always be a set of attributes and Y can also be a set of attributes. So we can also say that employee ID and employee first name both are determining employee last name. So X would be this set of attribute which is employee ID and employee first name. In the same way, we can also say that employee ID is determining employee first name and employee last name. So here Y is also a set of attribute. So this thing first we need to understand that X determining Y, X can always be a set of attribute and Y also can always be a set of attribute. Now how we will know the functional dependency in a given table? Now according to functional dependency definition, if there is a relation R, X determines Y, where X and Y are the attributes of the relation, and X can be an attribute or a set of attribute, Y can also be an attribute or a set of attribute, and Y is functionally dependent on X. Now here, can you say that X or the one which is a determinant is always a primary key? So can we say that X is a primary key? The answer is no. It's not always true that X will always be a primary key. This is a unique identification key, but it's not a primary key. It can be a primary key, but it's not important for X to be a primary key. It should always be a unique identification key. Now, how do we find that if there is a X which is present, or if there is an attribute which is present, is acting as a determinant or not? So as I told that it is not always true that it will always be a primary key. So there could be a possibility that there is some duplicacy in this employee ID column. So again, the employee ID is 1, the name is considered Ria, and the last name is Singh. So here you can see now employee ID is having 2 ones which is present in the table. So it is not unique. So primary key violation happens because this particular employee ID or this particular attribute doesn't have unique values. Now if we want to now see that if this employee ID determines employee first name is true or not for this particular table, what we need to do is if there are 2 tuples, or you can say 2 records, and the value of X is similar for both of the records, then the value of Y should always be similar, so that these are functionally dependent. So if there are 2 tuples T1 and T2, and if T1.x is equal to T2.x, that is this is equal to this, then T1.y should always be equal to T2.y for the functional dependency to exist. So let's see, is T1.x equal to T2.x? 1 is equal to 1. So this is true. So let's see if T1.y is equal to T2.y or not. So T1.y is Riti and T2.y is Ria. So is T1.y equal to T2.y? No. So now we can't say that employee ID determines employee first name, because consider that if I provide the employee ID 1, what would be the value of y it will return? Because right now 1 is having the value as Riti and 1 is also having the value as Ria. So now employee ID is not determining employee first name. But what if here the value is written as Riti? So now, is the employee ID determining the employee first name? Yes, because 1 is always corresponding to only one value. 1 is not corresponding to two values. 1 is always corresponding to only one value. So this is the criteria which we use to follow to find the functional dependencies which are present in our relation. So if there are two tuples who are having the same value, such as like the same record is present in that particular two tuples, then we should always check the value which is being determined or which is functionally dependent on that value. So if there is employee ID which is having values such as 1 and 1, then we need to check that what is the corresponding value to this one, because there could be a possibility that this one is giving me Riti and this one is giving me Ria. So 1 is having multiple values. 1 should always hold single value because this is a unique identification. If I say that 1 is also giving me Riti, 1 is also giving me Ria, so the unique identification does not exist. X shouldn't be a primary key. It can or it cannot be, but X should always be a unique identification. So this is called as functional dependency. So whenever we encounter that if there is an employee ID column which is having unique values or where there is a primary key, we don't need to check for all those things, because if it's a primary key, it will always determine some unique values only. But if there are some duplicacy which is present in this employee ID, then we need to check this condition that for given two tuples, if the value of X is similar, the value of Y should always be similar. If it's not similar, then it's not functionally dependent or the functional dependency does not exist. I know this can be a bit confusing, but when we will learn about normal forms, that would be clear more and more. For now, you can just understand that in functional dependency, there is a relation and then there are some attributes. One attribute is functionally dependent on another attribute. It basically means that if I know the value of X, I can determine the value of Y. X and Y can be a set of attributes. X is not always needed to be a primary key. It can or it won't be, but X should always be a unique identification key. That is, for one value of X, there should always be one value of Y. There shouldn't be a multiple values of Y. Now there are some properties of functional dependency, or we can also call it as inference rules. Now what are those properties? So the very first property is reflexivity. Now what is this reflexivity? So if there are two attributes X and Y, where Y is functionally dependent on X and X determines Y, we can say that if Y is a subset of X, then X determines Y or X determines X. Now how this comes X determines X? So here I told that Y is a subset of X. So Y is always having some values which is present in X. So Y will always have the value X. So we can say that X determines X. So a particular attribute can always determine itself and it can determine Y if Y is a subset of X. So X determines X always holds true in terms of the reflexivity property. Because Y is a subset of X, so Y would always be having values which are having X. So X determines X always holds true. Now the second property is augmentation. What does this mean? That if X determines Y and if we are augmenting Z here, then XZ should always determine YZ for any Z. So consider that there is an employee ID which determines employee name. Now if I augment or add something, so if employee ID, I add an employee phone number. So employee ID, employee phone number both together can determine employee name and employee phone number. So I can see that if something is added at LHS and the same thing is added at RHS, then there would be a functional dependency which will exist between this combination. Now the third one is transitivity. So what this transitivity says us, कि if X determines Y, so if X is an attribute which determines Y and then Y is an attribute which determines Z, then X is an attribute which will always determine Z. So if X determines Y and y determines z, then x will always determine z. We don't need to check for this dependency if this exists or not. If x is an attribute which determines y and y is an attribute which determines z, then we can say that x will determine z as y is common between them. So this is called as transitivity. Now the fourth one is union. Now what union says is, if x determines y and x determines z, since LHS is common in both the cases, we can say that x will determine yz. So since x determines y, x also determines z. So since employee ID determines the employee first name and employee ID determines the employee last name, then we can say that employee ID can determine employee first name as well as employee last name. So there is a union which happens whenever the LHS is equal. But the vice versa is not true. If I say yz determines x, I can't say that y will determine x and z will determine x. This is wrong, because again, yz is something which is a combination which is helping me for the unique identification, or this is a unique identifier or a key. So if the both of these key are helping me to determine one attribute, I can't say that a single attribute can determine this particular attribute, because the composite version of this is helping me to determine the attribute. So if x determines y and x determines z, we can say that x determines yz, but we can't say that if yz determines x, y will determine x and z will also determine x. That is wrong and that is not true. Now the fifth rule is rule of decomposition. So if x determines yz, we can say that x determines y and x determines z, which is the same which we learnt in union. So it's just the reverse of union. So if x determines yz, we can say x determines y and x determines z. So the determinant can never be broken. Determinant can never be broken. If it's a set of attributes, it can't be broken into single attributes and determine something, because the set of attribute is helping in the unique identification, not the single attributes, right? So this can't be broken. The RHS can be broken. The dependent can be broken, but the determinant can't be broken. Now, what are the types of functional dependency? So there are two types of functional dependency. One is trivial and the second one is non-trivial. There are more, but basically now we need to know about these two only, trivial and non-trivial. So let's see what is trivial. So functional dependency x determines y is trivial if y is a subset of x. So it says that if y is a subset of x, x can determine y and x can also determine itself, that is x. So this particular dependency is always valid. We don't need to go ahead and check in our table, because x can always determine x. Employee ID can always determine employee ID. If I say that employee ID is 1, find the employee ID in the table, I can always find the employee ID because I know the employee ID is 1 here. So x will always determine x. This is a valid dependency. This doesn't need to check that if there are some employee IDs which are present, if again there are some employee IDs which are present, because we are seeing in the same column, or you can say in the same attribute itself. Also, since y is a subset of x, y will be having values or the elements which is present in x. So we can say x will determine x. So we can also say it as x determines x. Now consider that here there is a dependency given where employee ID and employee first name is determining employee ID. Now this is y and this is x. Now in y we have employee ID and in x also we have employee ID. So we can say that y is a subset of x because the element which is present in y is also present in x. So we can also say that employee ID determines employee ID and employee ID, employee first name determines employee ID. Now this is trivial because employee ID is a subset of employee ID and employee first name. So we can say that trivial dependency exists whenever x intersection y is always y. So whenever we are doing an intersection between them, so we are doing an intersection between employee ID and employee first name. So in intersection we used to provide the common which is present between them. So in employee ID and employee first name, employee ID is the common one. So we give the value as employee ID for a result. So x intersection y always gives us y. Y is employee ID. So here we get the employee ID. So this is the trivial dependency. Now, what is non-trivial dependency? A functional dependency x determined y is non-trivial if y is not a subset of x. So, y is not a subset of x, basically, which means that if there are some values which is present in y, or if there are some attributes which is present in y, it's not necessary for that attributes to be present in x. So here if you can see, x is having employee name and y is having employee ID. So employee ID is not present in employee name, so y is not a subset of x. So these dependency needs to be proved, because so right now I am saying that employee ID is getting determined by employee name, or employee ID is dependent on employee name. But is this true? Like, we have to check that if this is valid or not. In trivial, what used to happen is x determines y and y is always a subset of x. So y always contains some element which is there in x, or y is always having some attributes which is in x. So this is always true. But when x determines y and y is not a subset of x, then we need to prove that point ki, okay, if employee name is determining employee ID, I can check from my table if this functional dependency is present or not present. So functional dependency x determines y is not trivial when the y is not a subset of x. So if there is x as employee ID and y as employee first name, we can say it is non-trivial because employee first name is not a subset of employee ID. So employee first name does not have any element which is there in employee ID. So here if we do x intersection y, we get 5, because x intersection y does not gives us anything, because there is nothing common between employee first name and employee ID. So it will give me 5 or it will give me empty. This was all about this video. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.